Hi everyone, my name is Jasmine Liu. I'm a PhD student at the University of Chicago, and I'm very excited to present this paper that was part of the Tokai special issue on unmaking. Today, I'm going to be exploring concepts of unmaking within the area of electronic waste. This work was done in collaboration with Pedro Lopes at the University of Chicago. Today, I'm presenting our findings regarding how we can learn from not just building and interacting with devices, which is what our field typically focuses on, but what we can learn from another part of a device's life cycle, one that is often missing in HCI discussion. The stage when devices become electronic waste. And this is part of my PhD work, where I explore and invent new interactive systems to help users engage with e-waste. But today's talk focuses more specifically on what we can learn from existing practices of taking apart or unmaking e-waste and reusing it for new purposes. By exploring the life of a device after it's useful, it actually brings new research agendas for human-computer interaction. Now, why focus on the issue of e-waste? Well, e-waste is the fastest growing waste stream in the world. 62 million tons of e-waste accumulated worldwide in 2022, with projections of 82 million tons by 2030. You might say, well, that's fine, we can just recycle it all. But not only is recycling inefficient, but it's only addressing the symptoms rather than the root issue, our rapid consumption and obsolescence of technology. Our recycling streams simply can't keep up with the massive amounts of technology being wasted. Instead, it's important for us to explore how and why e-waste becomes waste if we're to have any hope of reducing how much e-waste we generate. In our work, we argue that we should do so by looking beyond use. We believe the HCI community is uniquely positioned to explore this issue. But to do so, our conception of human-computer interaction must move away from only research on interactions during device use and towards interactions beyond device use, to also include interactions of recycling, repairing, and reusing. We approached our exploration by interviewing unmaking e-waste experts coming from a variety of backgrounds and a diverse set of experiences in reusing e-waste. These included artists, researchers, engineers, hobbyists, and repairers. We conducted semi-structured interviews with them and employed a reflexive thematic analysis with inductive and experiential approaches. Our experts detailed a wide variety of approaches and methods to unmaking and remaking with e-waste. We also use unmaking to kind of encapsulate all of these different practices, but let me highlight some. Most of our experts were deeply involved with e-waste reuse, creating projects by hacking together parts from waste, like extension cords, interactive artworks, or automatic gardening systems. We also had folks who had a lot of experience in e-waste repair, whether as a hobbyist finding neat hacks to fix a laptop, or professionally as a repair tech for audio-visual equipment. Finally, several of our experts were deeply involved in using e-waste as a means of educating others about e-waste, through the likes of teardown workshops and zines or critical making exercises. From our interviews, we developed 20 themes organized along these questions. What pathways brought our experts into unmaking e-waste? What processes did they engage in? What challenges did they encounter? What motivated them to unmake e-waste? And what cultures are already existing in unmaking e-waste? I won't focus that much on the first three questions in this talk, but what I do want to emphasize is that our findings for these questions emphasized how this is a very non-traditional approach that our experts are taking in unmaking e-waste. In fact, most electronics actively discourage the repair and reuse of them. Because of this, there's an extreme lack of tools and resources to support these processes, which poses a huge barrier even for our experts. To read more, highly recommend taking a look at our paper. I think these two themes in particular are especially interesting for our community. Unmaking as an alternative path of learning and the visibilities and invisibilities of e-waste. Unmaking allows us to expand the value of components beyond their original use in a device, such that more critical and creative engineering skills can be developed. Hacking, modifying, and repurposing devices empowers people to use their engineering skills in out-of-the-box ways. I really love this quote from Libby Rose Striegel that sums this up nicely. People are brought into the first level of following the steps of a kid, but there are no clear paths to the next. You can also use the blinking light switch to control a motor. They're the same thing. You can teach people that actually the output can be any number of things. We unintentionally narrow people's field of vision from the very start in electronics education in a way that doesn't facilitate the sort of exploratory creativity that taking something apart would be part of. Next, through our interviews, our experts detailed how seemingly e-waste was both highly visible but easily made invisible. Visible in that e-waste generation is part of the normal cycles of consumption and disposal of electronics, whether that's at home, in our workspaces, or in the communities we're part of. However, the issue of e-waste is often rendered invisible when it's not considered a priority issue to resolve, or when differing concepts of when waste can be useful lend to issues in recycling pipelines. I chose those two themes to highlight because I think they really nicely encapsulate what there is to gain from engaging in unmaking practices, and what areas of human-computer interaction we lose out on by ignoring the realities of e-waste. So, we also wanted to make a case to HCI practitioners to engage beyond just the use of devices. Much of our research frames evaluating new technologies based on their use, usability, or users. But doing so doesn't allow us to also consider the types of interactions that happen when devices are wasted. This is particularly relevant for device design. Devices should be designed not just for use, but also for unmaking, anticipating that obsolescence, breakdown, and decay will likely occur within a device's lifetime. We hardly ever evaluate devices in terms of their upgradability, repairability, or maintainability, methods to prevent them just becoming e-waste and instead allowing for continued use and reuse. And this is a significant space for HCI researchers to really do what they do best and invest in building out new tools like editors or devices, as well as new design and system paradigms to improve across these categories. Additionally, we need to involve a broader definition than just the user of the device. There are many more people involved in the device lifecycle that go beyond the traditional user interaction paradigm we typically think of. For example, consider secondhand users, repair techs, sellers, or upcyclers. Those all get left out of the picture when we only think of the traditional singular user. HCI researchers can better engage with these overlooked users and identify how our work can better support their practices. In my PhD, I have been actively exploring how HCI can contribute to those two areas, device design and reuser interactions, for mitigating e-waste. I've done this by creating new computational tools for unmaking e-waste, recommender systems with reuse hierarchies enabling recycling components from e-waste for new projects, like in this image, an electronic conference badge made up of parts from a broken toothbrush and a broken Roomba. Also, computer vision tools for PCB reuse, enabling you to reuse the PCBs found in e-waste for prototyping by abstracting away from the original design so that the PCB in a handheld gaming device can also be used to implement the circuit for a connectivity tester, for example. I've also done this by envisioning roles other than users by creating care-based interaction designs and illustrating how end users can be agents driving sustainable computing. And finally, rethinking e-waste recycling strategies, highlighting how common paradigms of recycling overlook the inherent modularity of electronics, as well as existing practices in reuse. And I think there are so many other research directions in mitigating e-waste that HCI is particularly well suited to address, and I hope this work will encourage other HCI researchers to contribute to supporting new methods of unmaking e-waste. Thank you so much. I'm so happy to answer any questions about the work over email or at the CHI conference.